Welcome to an introduction to chemistry, brought to you by Parkbench Tutors. For more information about Parkbench Tutors, just look us up on Facebook, or you can find us at parkbenchtutors.com. In this podcast, we're going to take a look at some of the units that we use in chemistry, or for that matter in the other sciences as well, and that is a system called the metric system. The metric system is also known as the International or IS system of units, and it's the one that is in common use in most countries. It uses factors of 10 to make bigger or smaller units, but there are basic units for mass, length, time and so on, and then the prefixes will show the size of that unit. So this is how the prefixes are used, and some are more common than others. So that, for example, the standard unit is 1, and so a tenth of that will be a deci, whatever it is, a hundredth of it will be a centi part of it, a thousandth will be a milli part, and you will come across micro, nano and pico units, more and more common these days, particularly in chemistry. If you're talking about bond lengths, you're talking in terms of nanometers. So what are our standard units? Well, for length, it is the meter. For mass, it's the kilogram. For time, it is the second. And those are the commonest units, the LMT series. And for temperature, it is degrees Kelvin, although you'll often find degrees Celsius is still in use. A very old-fashioned system would be degrees Fahrenheit. The amount, we normally measure amounts in mole now, currents in amps, and intensity of light in terms of candelas. So let's take measuring length as a simple example. The standard unit's the meter, and it's been defined variously over periods of time. A common method now is to define it as the distance light travels in a vacuum in a given amount of time. If we can relate it to the old imperial system, a meter is 39.37 inches. So let's look at some of the common measurements for length. The meter then is the standard unit. So 1,000 meters, we use the kilo to prefix it. So 1,000 meters will be the kilometer. And going the other way, if we take a 1,000th part of a meter, we shall end up as the millimeter. Note the abbreviation mm there. And note we can also express these to the power of 10. So a kilometer is 10 to the power of 3 meters, and a millimeter would be 10 to the power of minus 3 meters. Conversions. If you can understand how to set up a conversion, then it's fairly easy to work out the conversion as long as you know the factor. So all of them are going to follow one pattern. The old unit times the conversion factor is the new unit. So the old unit has to be cancelled out so that you can introduce the new unit. Well, what do we mean by that? There are 1,000 millimeters in a meter, so how many millimeters in 3.5 meters? So we put the unit in 3.5 meters times 1,000 millimeters divided by 1 meter. We cross out the meters, which means that the units we're left with are obviously going to be millimeters, and 3.5 times 1,000 is 3,500 millimeters. In the same way, how many meters are there in 450 centimeters? We set this up, 450 centimeters times 1 meter over 100 centimeters. The centimeters cancel out, so 450 times 1 over 100 will give 4.5, and the answer of course then is in the units to the left, 4.5 meters. Okay, sometimes you get more than one conversion. So if there are 60 seconds in a minute and there are 60 minutes in an hour, how many seconds are there in 2 hours? So here we've got two conversions, seconds to minutes, minutes to hours. So if we set up the conversion, 2 hours times 60 minutes over 1 hour, that'll convert to our minutes, then times 60 seconds divided by 1 minute, that'll convert to the seconds. And you can see that our hours are going to cancel out, our minutes are going to cancel out, So we're going to be left with 2 times 60 times 60, which is 7,200, and of course the unit that we're left with is seconds. Okay, sometimes we have to convert from different systems. For example, how many centimeters are there in 3 feet? We know there are 12 inches to the foot. We know there are 2.54 centimeters to an inch. So let's set up the conversion. 3 feet times 12 inches over 1 foot, that'll turn it into inches, and then multiply by 2.54 centimeters over 1 inch, that will turn it into centimeters. Okay, cancel out the units, and you can see that we're going to be left with an answer that's in centimeters. And to multiply that together, 3 times 12 is 36, times 2.54 gives 91.44. And we've expressed it to two significant figures there, but since the actual number of significant figures there is 3.0, we can actually say that we should only have 2 significant figures in the answer. We'll perhaps deal with a bit more of this later on in another podcast, but we could say that the answer then is 91 centimeters. Okay, let's have a more complex idea for conversion. A cyclist travelling at 14 miles per hour, how far in kilometers per second? So we've got to convert the miles to kilometers. We've also got to convert the hours into seconds there. So it's 1.609 kilometers in a mile, so 14 miles over 1 hour times 1.609 kilometers over 1 mile. Now add, I can do this all at once, so we add then the idea of converting to seconds. So 1 hour's got 60 minutes, so 1 hour over 60 minutes multiplied by 1 minute over 60 seconds. Okay, looking quite complex at the moment. Cancel out the units. First the miles, then the hours, then the minutes, and you can see we're left with kilometers per second. And if we want to do the maths, it will come out as 0.0065 second kilometers per second. And we started off with 2 significant figures, so we really ought to only take 2 significant figures after the 0, 0.0063 kilometers per second. That's the end of this short introduction to metric units. Thank you for watching and for listening. We wish you success in your studies. For more information about Parkbench Tutors, look us up on parkbenchtutors.com. If you want more information, you can of course sign up for our playlist, and we will soon have a playlist for our introduction to chemistry